I'll suddenly appear right here. And we're back to a commercial with more math. Okay, so now it's time to play one of our favorite games called. Well, yeah, that too, yeah. But there are only two types of discontinuity.
Removable and non-removable.
Removable or non-removable. That's one of our favorite new games, I guess. Okay? All right. So let's play removable or non-removable. All right. And yes, we can. Now, here is the deal with this problem right here. Okay? What's the deal with this problem? Okay, it's a little Seinfeld bit. Okay, so here's what we have to do. Either the top trinomial, 1, 2, 3, factors into x plus 2 times something, or it doesn't. Question mark. Okay, and that would be that. So, question is x plus 2 a hidden root in there, or is it not? Now, there are three ways to do this problem. You get the long way, the medium way, and super fast. That's right.
Plug it in.
Okay, long way. Use the rational root theorem to figure out all the roots. That'd be a pain. Well, in number 15, we have to use the rational root theorem. Let's just save it for that problem. Medium way. This isn't actually too bad. Couldn't you long divide x plus 2 into this right here?
Yeah,
that wouldn't take that long. That's not a bad option.
Just don't forget this square.
But make sure that's right. But make sure you get a 0 remainder and then x plus 2 is a factor. Okay? Or there's another way to figure out that.
Set it equal to 0.
Where is the neutral point in question?
-2.
X equals -2 would make that expression 0. Could we just put -2 into this mystery trinomial right here
Great idea.
and see if it gives us 0? Because if it gives you 0, that's not a coincidence in that. The only way that can give you 0 is if x plus 2 is a hidden factor of that trinomial, right? It's the only way. So let's just take -2 and substitute it, stick it in there, and see what happens. Okay, that was hard to guess. All right, -2 cubed is
-8.
-8 times 2, -16 minus 2 plus, ooh, so close.
Oh, equals 1.
Ah, very close. Not close enough though. Doesn't matter if it's 0.001, it ain't gonna work, right? So, turns out x plus 2 is not a factor. So therefore, you do not have this. This is preposterous. And if there is no factor of x plus 2, it will not cancel, and it is non-removable. We have a 50-50 shot of getting this right. It's either removable or non-removable, right? And remember English class, please drop the E before you add the able. Okay? All right?
Would we get counted wrong if we spelled it wrong?
Minus 1, I'm just kidding. I'll let it slide. But try to spell it right. Okay. And by the way, if there is no cancellation, what is actually happening on the graph? If there's no cancellation, vertical asymptote right down the middle, right at -2. Okay. If it does cancel, and there is an x plus 2, that creates a hole at a coordinate. There are only three types of discontinuity. Non-removable is vertical asymptote. Removable is a hole in the graph, and the only other type of discontinuity
Does not exist.
is
Oh yeah, the
disjoint, which is when you have two equations piecewise and they don't fuse together. You can't get it within a single equation. It's got to be two equations. Okay?
Okay.
So those are the only three types. That'll last you all the way through most of college. If you get like deep into college, you get some weird discontinuity cases for any future math majors. But even if you're an engineering major or computer science major, the only three types of discontinuity you'll ever see are whole, vertical asymptote, disjoint. So those will last you for a long time, which is the point of this class.
Green.
Because we're doing calculus. I mean, pre-calculus. Okay.
I saw integration on the list of things that we're going to do.
I can explain that. All right. Just the basics. Okay, now, find all the roots. If you want to find the roots of this, all I have to do is set it equal to 0.
Oh, no.
All right. We got it. That sound means it's time to use the rational root theorem. Very good.
Got this one.
Okay. Speaking about bars, the rational root theorem, was developed by the same person who found the Cartesian plane, René Descartes, our favorite Frenchman.
Descartes.
Okay, yes, Descartes. Okay, so, according to Descartes, by the rational root theorem, there, oh, by the way, side note, according to Euler, #1 mathematician of all times, what are the most roots you can get from a third-degree polynomial?
3.
Up to 3 answers, you can get no more than 3. It's impossible, right? To find all 3 of those answers, René Descartes figured out that in this puzzle
Plus or minus.
lie all 3 roots, if there are up to 3 that is. Okay? Plus or minus.
Factors of the last
Over one.
coefficient.
All the factors of
Last
70 over all the factors of
1.
1. And it will be 1 on the test. Okay? They hardly ever give you a 2 in this case. They'll give you a 1.
coefficient.
So, okay, go ahead and bank on that. All right, well, what about 70? Let's see, what goes into 70? 1?
2,
2 definitely, yeah.
5.
Yeah, not 3, not 4.
5,
5 does for sure.
7.
7 does, yeah.
Oh, wait.
Oh,
we
wait.
broke
Oh, the threshold. See, you guys are sharp. You guys are on the ball today. Didn't even drop a hint, you got it. All right. There is a threshold here, and it ain't halfway, that's for sure.
8.
Right? Isn't. Okay? 35 would be the midway point, but we know something more important. The square root of 70 would be
8 point.
8 point something,
Yeah.
right? Yeah. Okay? And by the sieve of
Eratosthenes.
clever. See this? Okay?
We should all get plus.
If independents or centennials watching this, we're kicking your tails.
Kicking your feet.
I mean, anyway, okay. So, once you get past the square root, the mirror has already been set, and everything else is just a product of this. 7 times 10. Ooh, 5 is half of 10, so
14.
double the 7 is 14. 2 times
35.
5, and 1 times.
I bet you it's negative positive 70.
All right, well, let's see. And no, hopefully not, hopefully not. And I will not give you some case where you have like 58 factors. I'll give you, that's like the most you'll have, okay? So, now it's time for an Easter egg hunt.
I like Easter egg hunts.
If there are 3 answers, actually there are 3 answers, I'll tell you that. They're all 3 hidden in this right here, this puzzle. Okay? So, first, let's try positive 1 over 1. Then we'll try negative 1 over 1.
And then positive 2.
Let's try positive 2 over 1
Let's
and
just
negative 2
start
over
with
1.
positive
Okay,
2.
hold on.
I think we should do positive 2 as
Positive 2 is a
well.
great
Nobody's-
idea.
It's always
Nobody cares about
been-
wonder and everything.
All right, now, I don't want you to try all of these all the way down to negative 70, okay? If you try the first 4, I promise I will put a factor within the first 4, all right? As they do at the end of the year exam. So, let's take these, and if that really is a root, what would happen that happened in the last problem we just
It would
did?
equal 0.
It would equal 0 when you plug it in. 1 cubed is 1, 1 times 39 is 39. That doesn't give me 0, does it?
No.
Okay, not 0. All right, let me try it. Negative 1 cubed is negative 1.
Plus a positive.
That's a positive 39.
Plus a bigger positive.
And that's even
That's
more
definitely
positive.
0.
Hey. Out of luck. All right, let me try one more.
I think you should.
Or
try
I mean,
2.
let me try 2 more, okay, just in case. All right, 2 cubed is 8.
8 minus 7.
Double 39 is
78.
70. Oh, ooh. It's all coming together. Look at this. Yeah, so much when it comes together. Plus 70.
Equals
Equals
0.
That's negative 70 plus, beautiful.
Check.
So nice when math works out.
Yay.
Okay, look at that. So the winner, or one of the winners, is 2. Okay? Now remember what we did in the last problem. What creates positive 2 to be a root? The
X
hidden,
minus 2.
there is a hidden factor of x minus 2 in there somewhere. It has to be mathematically. This is not a coincidence. Okay? So let's use long division, because we don't know the other 2.
Original
So you're
function.
missing
And,
a
and this is the fastest way to do this, believe it or not.
Don't forget the x squared.
Yeah, don't forget X.
Okay, this is a trick you have to watch for the test. If you long divide x minus 2 into this polynomial up here, it is x cubed.
Plus 0 x squared.
Put 0x squared because you need an x squared column. Very good. Okay? Minus 39x plus 7. Remember, this is the problem where we have like the x cubed column and the x squared column and all that? Okay, so x goes into x cubed how many times?
X squared.
X squared.
Stop.
And stop, right here, no enemies. Okay, put it in the appropriate column, all right? Press your luck. Okay, x squared times x is, wow, I'm so surprised.
Minus 2 x squared.
The whole goal is to try to get those to match. X squared times minus 2 is,
Minus 2 x squared.
okay,
Subtract that quantity.
and subtract. X cubed minus x cubed is,
0.
I'm so surprised. 0x squared plus 2x squared
2 x squared.
2x squared, something drop down.
Drop down?
Drop down the negative 39x. Okay? All right, how many times does x go into 2x squared?
2x.
2x. Everybody see the x column lining up right here? See that? Isn't that nice? 2x times x is 2x squared. 2x times minus 2 is minus
4x.
4x. And now we subtract. 2x squared minus 2x squared is 0. Well, we're also shocked. Negative 39 minus a minus becomes
Negative 35.
plus